Hi everyone, this is a quick overview of Chapter 12. It's kind of continuation of Chapter 1 where in parts of it they talk about the Earth's internal structure. Again, this is a quick picture of what the Earth looks like, and I mentioned before about the plate boundaries. In here we have three different plate boundaries. We have a divergent plate boundary in which you have within the oceanic crust, you have splitting, so to speak. We have a younger crust being formed right over here, kind of like the mid-Atlantic ridge, mid-oceanic ridge, and a converging plate boundary in which you have the oceanic crust with the continental crust, and then here you have the subduction zone in here. And then the other thing that thought I'd kind of go over is that kind of like Hawaii, the idea is that the Earth is the oceanic crust is moving and it's above a hot spot, and it's that hot spot, or as the crust moves, you have the formation of these volcanic islands, kind of like the Hawaiian Islands, and that's how they're formed. So you have this hot spot, this mantle plume, where you have a partially melted lava that's kind of bubbling up, and it's forming those lands that you have in the Hawaiian Islands. The other thing that we actually have is that we know that as soon as I can find that image that I wanted to show, we know that the Earth is made up of different layers, mainly because from seismic waves, seismic velocities, some of them will get refracted and some of them will get reflected. And what reflected means is that when you change, when a seismic wave comes through a varying material, either that wave, the seismic wave, is reflected, it kind of bounces off of that, or it goes through and then comes through that other wave, and that's what you would consider as a refracted wave. So if it goes through that material, then it's refracted, but if it bounces off, it's reflected. It's a reflected wave. And the other thing that's been stored within the rocks are the magnetic fields. So the Earth internal magnet has changed over the years, and all of that information has been stored within the rocks themselves. As it'll kind of it's changed over the years, the magnetic polarity, so that the rotation axis has kind of varied, and it varies within the different places of the Earth, so that when you have a GPS, a handheld GPS, not the electronic version, usually what you'll do is you'll set the magnetic declination to kind of counteract that magnetic north as opposed to the geographic north. And when we look at maps, we'll go into those, and the topo maps usually will have that information stored within it.